Welcome to this video training on Python's power for data analysis. We will deep dive into Pandas and explore how to automate your exploratory data analysis. Python is more than just a programming language. For analysts, it's like Excel on steroids. With 90% of data analysts using Pandas daily, mastering it is key to efficient analytics. In this video, we'll follow a roadmap from basic building blocks to generating automated EDA reports, ensuring you are capstone ready by the end. Let's recap the core Python basics: data types, conditionals, loops, and comprehensions. These are the fundamental tools you need for effective data analysis. Understanding data types, conditionals, and loops is essential. While Python loops are useful, we will learn how to transition to more efficient methods like vectorization. Mastering list comprehensions and functions will cover 80% of your common coding tasks. These two tricks are vital for clean, efficient, and reusable code. NumPy is significantly faster than standard Python for data tasks. We'll explore vectorization, broadcasting, random sampling, and aggregation to see why it's a staple for analytics. Vectorization removes the need for slow loops by performing operations on entire arrays at once. This, combined with broadcasting, makes NumPy incredibly performant. Random sampling and statistics are crucial for real-world analytics, from A/B testing to simulations. We will learn how to use NumPy for reproducible and reliable results. In this hands-on lab, we will demonstrate how to generate 1 million rows of data, perform calculations, and sample them in under 1/10 of a second. Pandas is the industry standard for a reason. Built on NumPy, it provides the powerful tools needed to clean, load, and analyze messy real-world data effectively. To understand Pandas, you must master its anatomy, the series as a column, and the data frame as the table. These are the core objects you will work with daily. When loading data, trust nothing. Always perform a quick diagnostic check to inspect for nulls, incorrect data types, and structural issues before proceeding with your analysis. Remember, nulls are a signal, not just missing data. Avoid filling them blindly. Instead, use strategies like dropping, median filling, or interpolation based on the context of your data. Finally, always handle duplicates, correct data types, and address outliers before starting your analysis. Following this cleanup sequence is vital to avoid skewed statistics and incorrect results. Now, let's look at the Pandas groupby function. It uses a split-apply-combine strategy that lets you generate complex management reports, like revenue by category, with just one line of code. Beyond grouping, Pandas simplifies pivot tables and SQL-style joins. You can create 360-degree business views or pivot data for dashboards without the manual clicks required in traditional tools. For custom logic, use apply, map, and apply map. While powerful, remember that vectorization is always faster, so use these tools primarily when vectorized alternatives are not available. Exploratory data analysis, or EDA, is where you find the patterns and anomalies in your data. You can perform manual checks or use automated libraries to find insights faster and reduce bugs. To wrap up, follow this 5-step workflow for your capstone project. By cleaning, transforming, and automating your reports, you turn raw data into actionable insights efficiently.